Hello and welcome to our lesson on Introduction to Polynomials and Polynomial Functions. This is going to be from section 4.1 in our text. We're going to jump right into the examples to start explaining all of the wonderful concepts involved in this lesson. Number one, we have a polynomial, negative 9x to the fourth minus x to the third plus 7x squared plus 6x minus 8. And there are some questions that they want us to answer. And we'll start with part A. Part A says, identify the terms. So you're going to need to know how to identify terms of a polynomial. It turns out that terms are separated by plus or minus signs. So negative 9x to the fourth, that would be a term. Negative 1x to the third would be a term. 7x squared plus 6x and minus 8. So in this polynomial, we have 5 terms. If you're going to list those, you would simply say negative 9x to the fourth, comma, negative x to the third. You don't have to write the coefficient of 1 if you don't want to, comma, 7x squared, comma, 6x, comma, and negative 8. And the negatives are necessary, but the pluses are not, because if you don't put the plus, it's understood positive. So that would be the answer to part A. Those are the terms. Part B, it says, what is the degree of each term? So we need to list the degree of each term. So the degree of a term is the power of the variable. So the degree of the first term here would be 4, 3, 2. The 6x, his power is 1, understood 1. And the negative 8, which is called the constant, also has a variable, but it's a hidden file. That would be x to the 0. Now, the reason that is because anything to the 0 power is understood to be 1. And 1 times negative 8 would leave negative 8. So that's going to be a degree of 0 because that has an understood x to the 0 power. Part C, we need to identify the degree of the polynomial. Once you have identified the degree of each term, the degree of the polynomial is simply the highest of those degrees. So the degree of the polynomial here would be 4 because it is the largest degree on any term. D, they want me to identify the leading term. Now, you would think the leading term, well, is the one out in front, the one in the lead. And in this case, it is, but not because he's first, it's because he has the highest degree. So whichever term has the highest degree is the leading term. In this case, that is negative 9x to the fourth. Next, E, identify the leading coefficient. Okay, so once you've identified the leading term, the leading coefficient is the number in front of the letter. Or you could say the number that's multiplied by the variable. Here, our leading coefficient is negative 9. And for the last part, they want me to identify the constant. And a second ago, I said that negative 8 was the constant. The reason is because he's the number without a letter, if you want to say it that way. The constant is the term that has no variable showing. Or you could say the constant is the term that has a x to the 0 power. There's several ways to say that. Probably the easiest way is the constant is the number with no letter, the number without a variable. So here the constant is -8. And in that one problem, we introduce you to all of the concepts that you need to know. You need to know how to identify terms, how many terms, the degree of each term, the degree of the polynomial, the leading term. Of course, the leading coefficient comes from the leading term, and you need to know how to identify the constant. And that is going to do it for our first example. All right, for our next example, number 7, the instructions say to arrange the polynomial in descending order. And descending order means that the degree of each term needs to start at the biggest and go down to the smallest. So which term has the largest degree? Which variable has the biggest power? That's -4y to the third. So he would come first. And guess what else that makes him? That makes him the leading term. And -4 would be the leading coefficient. Just to reiterate a couple of things there. Next, we would have -6y squared. So if you notice, the exponents are stepping down. 3, 2. Next would be 1. So plus 7y, because he's got an understood 1 for a power. And lastly, the constant, which is +23. Notice he doesn't have a sign out front, so he's understood positive, and so I do have to write that plus sign. And that is the polynomial in descending order. And before I move to the next example, let's cover a few of those previous concepts again, okay? So what would be the degree of this polynomial? Well, it would be a degree of 3, because that is the biggest power on any letter. The leading coefficient. What would be the leading coefficient? Well, that's -4, because this is the leading term. So his coefficient is -4. And constant. Which term is the constant? And remember, that's the number without a variable. So that's going to be plus 23. Of course, you don't have to put the plus if you're just listing the constant. It's just 23. And that's going to do it for that example. All right, number 4. I felt the need to go back and cover a concept that I shouldn't have glossed over. You're going to notice that on number 4 here, if we're going to list the terms, what I'd like to do this time, instead of writing them out, I want to ask you how many terms are there, just to make sure you understand what is a term. Remember, I said terms are separated by plus or minus signs. So you could almost just go through and draw a separator at the plus and minus signs and then count up the terms. It is just that easy to figure out how many terms there are. So this particular problem has 4 terms, and it's the part B that we need to make sure that you understand. So the degree of each term, previously I said that that is the exponent on each variable, but you're going to notice in this problem that we have a term that has 2 variables in it. Okay, so this term is made up of 2 factors. Factors are things that are multiplied, and so that's going to make calculating his degree different than the other terms. So for the first term, the a squared, his degree would be 2. The 9b to the 5th, his degree is 5. And then the -a to the 4th, b to the 3rd. When you have a term that's made up of several variables. In order to calculate the degree of that term, you have to add all of the powers. So the degree of this term, negative a to the fourth, b to the third, would be 7. And then the last term, the negative 11, again, remember that's the constant, and a constant always has a degree of 0. So that is the main thing I wanted to point out in this particular example, is how you calculate the degree of a term with several variables. All right, in our next example, number 19, here we have a polynomial function. P of x is y. Remember, f of x, g of x, the function notation represents y. And this problem has several parts. Here they want to see if you know how to evaluate a function. So for part A, they're going to ask us to find P of 4. So what that means, it means that the 4 is going to take the place of every x in the function. That's going to be 3 times, instead of x squared, it's going to be 4 squared. Minus 2 times, again the x gets replaced with the 4, plus 5, and then this, all of this in the red bars, you're going to simply work that out and give the answer. Now, of course, you can do that manually according to the order of operations, but you can also do it electronically with the calculator. So I can say 3, and I can do times either with the parenthesis, like that, 3 times 4 squared, or I can just do 3 times 4 squared. Since the number that I'm evaluating is not negative, then the parentheses are not mandatory. Minus 2, again, I can just say times 4 plus 5, and we get 45 for the answer. So again, I want to point out again, to do this arithmetic, you can do it manually or electronically, either way. In fact, if you do it by hand, manually, I would recommend you use the calculator just to check it. Part B, here we want to calculate P of negative 2. So we're going to plug and play again. That's going to be 3 times negative 2 squared minus 2 times negative 2 plus 5. Again, every x gets replaced with negative 2. And this time, if you use the calculator, the parentheses are mandatory. So I think what I'll do this time is I'll show how to do this manually, and then we'll do it electronically. Okay, here we go. So exponents first. Negative 2 squared. Negative 2 squared is positive 4. So that'll become 3 times 4. Oh, and look what I've got here. Negative times a negative makes a positive. So that'll be plus 4 plus 5, which will be 4 times 3, that's 12, plus 4 and 5 is 9, and that is 21. And you can probably see there why I prefer to use the calculator. It takes a little too much manual labor, and I'm lazy. I mean efficient. I'm efficient. Okay, so here we go with the calculator, again proving that you have to put the parentheses. Let's do it without 3 times negative 2 squared minus 2 times negative 2 plus 5, and you'll see that we get a different result. It's because that negative 2 squared there, it's not actually squaring negative 2, it's squaring the 2 and then making that negative. So the correct way to input this would be 3 times negative 2 squared, like so, minus 2 times -2 plus 5. And we get the correct answer there. All right, we have one more part to do, part C, and that wants me to calculate P of 0. Now listen, P of 0 has a shortcut. Anytime you're replacing x with 0, every term that has an x is going to go to 0. So P of 0 will always be the constant. And that's going to do it for that example. All right, number 27 is our next example, and this is a word problem. It reads, a firm is marketing a new style of sunglasses. The firm determines that when it sells X pair of sunglasses, its total revenue is. And so right off the bat, we're going to make a note here. X is the number of sunglasses produced, and that means that R of X, remember the function notation represents Y, so you could say in this case Y represents money. The total revenue is the amount of money they make. All right, so knowing that, part A says, what is the total revenue from the sale of 50 pairs of sunglasses? So since we made a note over here, we know that X represents the number of sunglasses. Here I'm given a number of sunglasses, so I know that that is going to take the place of X. And I'm going to be calculating R of X, or in this case, R of 50, and whatever I get will be the revenue. So that'll be 240 times 50 minus 0.5 times 50 squared. And I'm going to use my handy dandy calculator for that. 240 times 50 minus 0.5. What are you upset I didn't put the 0.5? You can do that if you want, or you can just put 0.5. Either way is fine. Bam, bam. And then times 50 squared. And equal 10,750. $10,750. And that's the answer for part A. Part B says, what is the total revenue from the sale of 95 pairs of sunglasses? So this time we're going to replace every X with 95. And then we're going to pull out our handy dandy calculator and calculate that. All right, here we go. 240 times, and I'm going to use parentheses this time just for fun, times 95 minus, and I'm going to do 0.5 again just for fun this time, 95 squared equals, now on my calculator, remember it defaults to a fraction, so I'm going to have to hit the SD button so that I can see the dollars and cents. So for 95 pair of sunglasses, the revenue, the money I make is $18,287.50. So again, since that's money, you need to write out the dollars and cents. Next, number 43. Here we are given a long polynomial, and the instructions say collect like terms. Another way to say that, combine like terms. Okay, so you need to know how to combine like terms. First of all, how many terms are there? 1, 2, 3, 4, 5, 6, 7 terms. So we need to collect, or you can say combine like terms. So what we'll do is we'll start with the lead term here, the 8x squared, and we're looking for any other x squared. So there's one. and his coefficient is understood 1. So 8 plus 1 is 9x squared. So next, do you want to just move to the next term, the negative 3xy? We can do that. Notice that this term is made up of a product of x and y. Here we can see another product of x and y. So that term is going to be like this term. And if I add their coefficients, negative 3 plus 5 is a positive 2xy. 12y squared minus y squared plus 4y squared. All of those terms are like terms because they all have a y squared. So I've got 12 minus 1, which is 11, plus 4, which is 15, y squared. And so now to rewrite that where you can actually probably see it, 9x squared plus 2xy plus 15y squared is the final answer because none of the remaining terms are like terms. And it doesn't say to do anything else. It doesn't say try to factor that or solve it. It just says combine like terms. And that's all you need to know how to do there. All right, a couple more examples and we're going to be done with this lesson. Number 48 here, the instructions say add. On a test, it may say perform the indicated operation. So the indicated operation here is addition. And since I'm adding two trinomials, really what that boils down to is CLT. I need to combine like terms. So I'm going to start with the y squared term. I've got 11y squared plus 9y squared. 11 plus 9 is 20y squared. Okay, next, and again, let's try to color code this. I've got 6y plus a negative 2y. So what is 6 plus negative 2? That's the same as saying 6 minus 2, which is 4. So that's going to be plus 4y. And we're going to go with purple for the last time through. I've got the constants. Negative 3 plus 9. That is a positive 6. And that is the answer. And for our last example in this lesson, number 67, we have subtraction of polynomials. The instructions actually say subtract, but like I said, it could also say perform the indicated operation. And since we have a subtraction, this minus means that it applies to every term in the parentheses. So instead of just combine like terms, you're going to need to CTS, CLT. CTS, you're going to have to change the signs and then combine like terms. Can you remember that? When you've got subtraction of polynomials, CTS, CLT, change the signs, combine like terms. So the first set of parentheses is just going to come down. Since there's no sign in front of the parentheses, that's an understood plus. And a positive means that those terms are going to remain the same. They're not going to change. But the minus in front of the set of parentheses has to distribute and change the signs. Negative times a positive makes a negative. Negative times a positive makes a negative. And a negative times a negative makes a positive. So again, that's going to change the signs And then you need to combine like terms. Starting with the x squareds, -3 and -1 makes -4x squared. Next, 2x minus 5x, 2 minus 5 is -3. Last but not least, we have the constants. 9 and 4 is 13. And that is done. If it just says perform the indicated operation, or if it just says subtract, once you finish combining like terms, stop. That's all they want you to do. And that is going to do it for this lesson. So if you have any questions or comments about anything that I've done, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.